Hello everyone, thank you for joining us in this session of Spokane Public Schools Keep Learning Series for Literacy. Today's lesson is for all our fifth graders out there, and any child who is interested is welcome to join us. My name is Mrs. Rich, and I'm a fifth grade teacher at Woodridge Elementary in Spokane Schools. I will be your teacher for this lesson. I'm so glad you are participating with me today. This is our second lesson in this series. If you didn't see our previous lesson, you can find it on the KSPS website. You can still tune in today to today's lesson if you haven't seen any of our others. Today we'll be learning how an author uses details to support their claims. For today's lesson, you'll just need pencil and paper. I'll go ahead and give you a moment to gather your supplies. Okay, let's go ahead and get started. Today's lesson is called Storm Clouds Are Coming. So here is our focus for today. How the author uses details to support claims. We're going to read the text, we'll work together on an assignment, and then you'll get an independent activity to try out on your own. So before we get started on today's text, we're going to take a look at information we gathered from the last text we read, Tucket's Travels. So the children were traveling on the Oregon Trail, and I've found a map here. And on the map, it shows how the route went on the Oregon Trail. A huge storm passed through with a deluge of rain and huge hailstorms. And you remember Francis was talking how painful it was because these hailstones were the size of like baseballs. Some states on the Oregon Trail and states in Tornado Alley, which we're going to be reading about today, are the same. And if you notice, Nebraska occurs on both of those maps. The storm in Tucket's Travel was almost deadly. We learned that had the kids not been in higher ground, they could have been caught in a flash flood, and that could have killed them. Plus, the lightning came through, and members skirted past Francis's hair. So why do large storms form in this region? Well, that's what we're going to learn about today in our text called Spinning Thunderstorms. So here's our essential question for today. The author of Spinning Storms claims Tornado Alley is a perfect thunderstorm factory. What evidence supports this claim? So we're looking for specific details the author includes to prove that this statement is true. We're going to be looking at headings. We're going to paraphrase our answer by combining information from the text into sentences written into your own words, and we'll make sure we use at least two pieces of text evidence to support our thinking. Remember, one isn't strong enough. We need two or more to really prove that what the author is saying really exists in the text. So let's go ahead and get going into our text today. All right, so the first text we're going to look at is called Hurricane Storms from the Sea. And this comes from the American Museum of Natural History. So if you're interested in learning about more, you can head there and look for more information. What we call a hurricane is called a typhoon in Asia and a cyclone in the South Pacific, but they're all the same thing. A rotating storm that forms in the tropics near the equator and has winds of at least 120 kilometers per hour or 74 miles per hour. So what causes hurricanes and how do scientists study them? Let's find out. Hurricane Sandy storms into New York. In late October 2012, Hurricane Sandy devastated parts of New York City and the surrounding area. The hurricane was huge, but it was not the windiest storm to ever hit the area. Sandy's biggest threat was the huge pileup of water called a storm surge those winds produced. On top of this, the massive storm surge hit at almost the same moment as an unusually high tide. So it was very ironic that the tide was already higher anyway, and then these winds were causing that storm surge, which really made what they say is the perfect storm for issues to occur. New York City has 835 kilometers or 520 miles of coastline, much of it low lying, so officials expected flooding. But the deluge was worse than anyone thought it would be. In lower Manhattan, seawater poured over flood walls, flooding roads, subways, and electrical stations. Many were left without transportation or power. The seaside communities were hit worse. As waves crashed into the coast, the storm surge flooded homes and businesses, destroying entire neighborhoods. In the end, the storm took 43 lives and left many people injured and without homes. It also caused $19 billion in damage. And as with a nonfiction text, I always look at all the pictures and the captions, and these are really helpful in this case. So they're showing how the different places were impacted. So this is Battery Tunnel in Manhattan. The coastline, you can see that it's pushed through here and taken out the whole bottom of this house. Here it's knocked over trees in Connecticut, so it not only hit New York, it hit other states as well. And then here's the subway. So when the water flows through there, because the subways are underground, obviously they can't run the subway system, and they said the roads were closed as well because they were flooded, so nobody had the opportunity to get anywhere. Mantelocking is a barrier island on the New Jersey shore, about 95 kilometers or 60 miles south of Manhattan. These images taken before and after the hurricane show how storm waves cut across the island, eroding the beach and destroying houses and roads. So here's what this Mantelocking looked like before, and you can see the huge coastline it had and the ability to go, and now look what happened after Hurricane Sandy. It just demolished that coastline. So you can imagine any of the houses that were there too were greatly affected by it. So coming together. Many helped with relief efforts. The National Guard, Red Cross, local agencies, and citizens streamed across New York and New Jersey to remove debris and distribute emergency supplies to those in need. So here's a picture of the National Guard, and they're helping people get food because a lot of people, they can't go to the grocery stores or anything like that, and a lot of those places are wiped out. So what causes a hurricane? 1,000 miles across, Hurricane Sandy was the largest North Atlantic hurricane ever recorded. Find out how the sun's heat and Earth's rotation can turn a simple thunderstorm into a fierce, swirling hurricane. So here's a great model that shows us what they're going to be talking about. So how does a hurricane form? In the simplest terms, the sun's heat and the Earth's rotation lead to hurricanes. Near the equator, the sun's intense rays warm vast areas of the ocean. So that's what this is showing us here. And I love the diagrams because sometimes it's confusing, and so the diagrams really help me to understand what they're talking about. The sun's heat causes ocean surface waters to evaporate. The warm, moist air rises, cools, and condenses to form clouds. If the air is warm enough, large thunderstorms can form. Remember, that's what happened in our story with Tucket's travel, was that giant thunderstorm came through. So here's a great illustration of showing that how these clouds are coming together. So several large thunderstorms cluster together. Earth's rotation causes the winds to swirl around its center and wind speed increasing, and that's what those arrows are showing us. And this is what you might see on TV when they're showing a hurricane, maybe the direction and how it's moving. If wind speeds increase to 63 kilometers or 39 miles per hour, it becomes a tropical storm. If winds reach 120 kilometers or 74 miles per hour, it becomes a hurricane. And this is showing us the path of how it's traveling to land. As a hurricane travels over warm ocean waters, it is fueled by heat and water. As it moves over land, its heat supply is cut off and the powerful storm weakens. So how do scientists track and predict a hurricane? Satellites. Tracking storms from space. Not long ago, hurricanes would arrive without warning, but since the 1960s, satellites have helped meteorologists identify and track developing storms. Infrared sensors on satellites reveal information about temperature and humidity, conditions linked with hurricane formation. Today, satellite data can be transmitted in seconds. So, hurricane hunters. This is an example of hurricane hunters that go in airplanes to track the hurricanes. Now, what I noticed as I was reading is this paragraph starts out exactly like the last one. So they inadvertently printed the same paragraph twice. So we don't need to read that one because we've already read it above. But here's a computer model predicting a hurricane's path. And notice the text starts right here. So it's really important to look at all the text to make sure you're not missing anything. Meteorologists enter data from satellites, aircraft, and weather stations into a computer model. They use these models to predict the formation, path, and strength of hurricanes. They also use models to predict a hurricane storm surge and potential flooding. preparing for a disaster. So now we're going to learn, how do we get ready in case we live somewhere that would have a hurricane? Know what types of disasters could happen in your community. Know the warning signals, evacuation plans. Now, can this happen in Spokane? No, because we don't live near the water and we don't live near the equator. Prepare a disaster plan for your family that includes where to meet, who to call, and what to do with pets. Practice your plan to make sure everyone knows what to do. Keep a disaster supply kit on hand. And then here's an example of things that you should have in your disaster supply kit. So really the one thing that we practice for is fire drills, because that's the one thing that would definitely be a possibility in our area. So this was all about hurricanes. Let's jump over to our next text. So our second text is called Spinning Thunderstorms. Notice how both hurricanes and the tornadoes we're going to read about all start from thunderstorms. So that's what they have in common. On a spring night in 2007, disaster struck a small town in Kansas called Greensburg. Shortly before 10 p.m., a siren went off. A mile-wide tornado was approaching Greensburg, and it just wasn't any tornado. It was a category EF5, the most powerful kind there is. Its winds were estimated to be more than 200 miles per hour. In less than 10 minutes, the town was destroyed and 10 people lost their lives. When the fury had passed, people clambered through the rumble. Cars and trucks had been thrown about. Homes were crushed or simply ripped from the ground. I'm in downtown Greensburg. There's really nothing left, said one resident. And this photograph really kind of puts it up front for us. It shows us exactly, what those people were going through. How do tornadoes form? So just like hurricanes, we're going to find out how tornadoes form. A tornado is a swirling funnel-shaped column of wind that gets its start from a thunderstorm. Thunderclouds form when warm, wet air collides with cool, dry air. Then strong winds form into a wide tube of spinning air. When the tube touches the ground, it becomes a tornado. Here's a great picture of a tornado. A lot of times they have tornado hunters as well, and they go through and track these and then take pictures of them for us. Kansas are used to tornadoes. The people of Greensburg live smack in the middle of Tornado Alley. Oh, and we really want to pay attention because remember that was part of our essential question. An area that spans 8 states in the central United States. This region is a perfect thunderstorm factory. It has just what storms need to get started. Cool, dry air from the Arctic mixing with warm, humid air from the Gulf of Mexico. Above the flat Great Plains, far from mountains and coastal weather, thunderstorms can form undisturbed. These conditions spawn more than 600 tornadoes on average in Tornado Alley every year. Now, could we get tornadoes here? Not likely, because what do we have that this region does not? Mountains, lots of them. So here's a great map, again, showing us the Tornado Alley. How do scientists predict dangerous storms? So again, like the hurricanes, we're learning how they can track and predict these storms. Meteorologists are scientists who study and forecast weather. They use a technology called radar to track storms. Weather radar works by detecting the precipitation, rain, snow, or hail in approaching storms. The radar unit sends out a radio wave towards the storm. The radio wave bounces off the raindrops, hail, or snow that is in the storm, and then returns to the radar unit. The amount of time it takes for the wave to return tells meteorologists how far away the storm is. Most radar units send out about 1,000 radio waves per second. This gives them detailed, up-to-the-minute information about the storm. Using radar, forecasters can track the formation and path of severe storms like tornadoes. When a tornado takes shape, its winds blow raindrops in a circular pattern. When scientists see that pattern on a radar screen, they know that a tornado is developing. Although tornadoes have fast swirling winds, tornadoes themselves move relatively slowly across the land, only 18 to 30 miles per hour. So scientists can make reasonable forecasts about where they are headed. A system of tornado watches and warnings are used to alert the public to danger. A tornado watch means thunderstorms conditions exist that could spawn tornadoes. A warning means a tornado has touched down and been spotted. So here's a picture of a Doppler Radar Map. So again, this might be what you see on a forecast if you're watching the news at all and they talk about tornadoes happening. This system saved many lives in Greensburg. After the tornado siren shrieked, people had 20 minutes to escape to their basements and storm shelters before the tornado destroyed their town. Okay, so we've finished both of our texts. Now we're going to head back, relook at that essential question, and see what evidence we have that the author uses to support their claim. So first of all, we're going to take a second look at our essential question. The author of Spinning Storms claims Tornado Alley is a perfect thunderstorm factory. What evidence supports this claim? And then we're going to pull up the text and see what we found. So Kansas are used to tornadoes. The people of Greensburg live in that tornado alley, which we talked about. What do we need to make that thunderstorm? Cool, dry air from the Arctic mixing with warm, humid air from the Gulf of Mexico. They need to be above the flat Great Plains, far from the mountains and coastal weather. Thunderstorms can form undisturbed, and that flat land allows it to continue to build speed, which is what they need. These conditions spawn more than 600 tornadoes on average in Tornado Alley a year. So I've highlighted the text I'm going to use. Now I'm going to head to write my paragraph. Remember, I'm not using exact language from the author in the text. I'm synthesizing and putting together everything in my own words and then writing my paragraph from that. This is the example that I came up with. The 8 states that make up Tornado Alley are the perfect breeding grounds for thunderstorms. Cool, dry air from the north mixes with warm, humid air from the south. The flatland allows thunderstorms to form, and because there are no mountains, these storms grow in power and become tornadoes. More than 600 tornadoes form in Tornado Alley each year. So that's what we've done together. Now it's your turn to give it a go. For your independent activity, you're going to use the other article that we read, Hurricane Storms of the Sea, and the author claims in that article that the storm surge was the biggest problem during Hurricane Sandy. What evidence did he provide that supports this claim? So when you're writing your answer, be sure to include part of the question in your answer. You're going to paraphrase the text evidence by writing in your own words. And remember, it's important to have at least 2 pieces of evidence or a little bit more, okay? Because that really supports the idea that the author has proven to you what the claim is. So it's been great working with you again. I look forward to seeing you next time.